Namaste everyone. Today we are going to discuss a new chapter called trigonometric function. Now, trigonometric function. Now, in 9th standard and 10th standard, we have already seen what is a trigonometry. So, we will continue the journey here. But before we start discussing trigonometry, we will first discuss angles. Angles we all know what is an angle. So you can say that angle is formed by two rays, okay, whose initial point is same. So this is what I drawn an angle. I can name it as AOB. So this is an angle. Its measure could be anything. So if measure is unknown, we can represent it with some symbol as theta. So here angle is theta. This theta could be 30 degree or 45 degree, whatever. Yes. Now, while drawing an angle, what we are doing? We are rotating. This arm is called initial arm. We call this as initial arm, or we call this as initial side, and this arm is called terminal arm. So in angle, what we do? We rotate this initial arm at this initial point to some angle, an angle. So here, if I can rotate this in anti-clockwise direction like this, I can rotate like this, or I can rotate this initial arm in clockwise direction like this. So this is my initial arm, this is my terminal arm. When I rotate in clockwise direction, this is my initial arm and this is my terminal arm. So in school level we have not discussed all these things. There we have only seen that yes, when we rotate an arm, we will get an angle. Now here, why I am discussing these two things? Okay, you can see that here we have rotated anti-clockwise, here we have rotated clockwise. Maybe the same angle, say, let us say, we have rotated by 33 degrees Celsius, and here also we have rotated by 33 degrees Celsius. Now we want some concept so that this rotation 33 degrees Celsius, whether I am rotating in anti-clockwise or I am rotating in clockwise, I will understand by the angle itself that in which direction I have rotated the angle. So here I am using the word direction. So then when I talk about direction, I call that as a directed angle. So this is directed angle when I am showing the direction. There is only two directions, either I will rotate in anti-clockwise or I will rotate in clockwise. So to make our understanding clear, or to make it simple, what we done, we used negative angles whenever we rotate clockwise, and we used positive angles whenever we rotate anti-clockwise. So in the second figure, as I am rotating in clockwise direction, I will use word minus, I will use sign minus. So I will say that this angle is minus 33 degree and this angle is 33 degree. So you have understood. Whenever, now angle could be negative also. So far we have seen only positive angles. Now angles could be negative also. So when angle is negative, when your initial arm is rotating in clockwise direction, the angle will be negative. So whenever we specify negative angle, it means it is rotated in clockwise direction, or whenever there is a clockwise rotation, we will say this is a negative angle. Okay. Now we can rotate this initial arm, okay, in such a way that we will again come to the same position. When we rotate this initial arm in such a way that we come to the same position, then in that case the angle which is described at the center is considered as 360 degree, and this is called a complete angle. This is complete angle. So what is a complete angle? It is a complete rotation of initial arm. Using this, we can define 1 degree angle. Now 1 degree angle, what we say that 1 degree angle, right? Tell me what is 1 degree angle. So it is 1 degree angle is 1 upon 3/60th, okay, 1 upon 360 of complete angle. So this is your definition for one angle. What is one angle? It is 1 upon 3/60th of complete angle, or 3/60th part of a complete angle is your 1 degree angle. Now 1 degree, this is represented like this, 1 we will say, and on the top of it we will write a circle 0. This is 1 degree angle. Now in your geography, you must have seen your latitudes and longitudes. They are also expressed in angle, but there you have seen some other symbols like 35, then you have seen 35 degree, then you have seen something like this 5, okay, like this. Okay, what is this? So this is actually a part of angle. Okay, as meter, okay, we can divide in centimeters, centimeter we can divide in millimeter, hours we can divide in minute, minutes we can divide in second. Okay, for precise measurement we will divide them. So to do a precise measurement of angle, we divide these angles in subparts. So what division we have used? So we have used that we will divide this 1 degree in 60 part. So 1 degree will be equal to 60, but 60 what? 60, we use this sign and we read this as 60 minute. So 1 degree is equals to 60 minute. Okay, so 1 degree we can divide in 60 small parts and each part we call 1 minute. Clear? Okay, similarly 1 minute we can divide in 60 parts and each part we will call second. So 1 degree can be divided in 60 minutes, 1 minute can be divided in 60 seconds. So this is conversion from degree to minute and minute to second. Now angles, here we have discussed angle 360 degree. So is maximum angle 360 degree only possible, or we can have angle more than 360 also? So if your initial arm, suppose this initial arm rotated once, you got complete angle 360 degree, but it rotated further and suppose it goes till this point and you have this angle. So what will be the measure of this angle? This is complete 360, then I have something more, maybe let us say 60 degree. Suppose this part is 60 degree. So my total angle will be 360 plus 60 degree. So that is equals to 6, 6, 12. So this is 420 degree. So this angle is 420 degree. So my angle could be more than 360 degree. Okay, it could be more than 360 degree in anti-clockwise direction. It could be more than minus 360 degree in clockwise direction. So angle in anti-clockwise and clockwise we have seen. Now as distance can be measured in feet, distance can be measured in meter. Okay, similarly angle also can be measured in different systems. Okay, systems like FPS system we have seen, MKS system we have seen, SI system we have seen. These all we know from our physics concept. Okay, similarly these angles, they are measured in degrees. They can also be measured in some other unit called radian. Now when we measure them in degrees, we refer this as sexagesimal system of measurement. Sexagesimal system of measurement, in which we define one complete angle as 360 degree. The other measurement system is radian system, radian. And for this we use sign this half circle, or we can say that C, radian system. Now in radian system, how we define 1 radian of angle? So for that I will draw a circle Now in this circle, let us take center and draw a ray. This ray cut the circle at one point. Let us mark this point as P. Now along this circumference, I will move a distance which will be equal to radius of this circle, and I mark that point Q. Now this distance PQ along the circumference will subtend an angle at the center. Okay, so what is this angle? How much is this angle? We don't know, but it subtends some angle at the center. This angle subtended at the center, okay, let us I will not mark this as theta because this is some specific angle. Here we have moved a distance equal to r, radius of the circle. This angle which I will get at the center, that angle I will define as 1 radian angle. So this is 1 radian. 1 radian along the circumference, if we describe a length equal to radius of the circle, then angle subtended by that arc at the center of the circle will be considered as 1 radian. So by using this concept, if the distance is equal to 2r, then it will be 2 radian. If it is 3r, it will be 3 radian. If it is equals to 2 pi r. So for r, the angle we got is 1 radian. For 2r, we will get angle as 2 radian. Similarly, for 2 pi r, we will get angle as 2 pi radian. So when we get length 2 pi r, when we again come to point P. So this gives me an idea of complete angle. So therefore complete angle is 2 pi radian. Now in degree system we have seen that 360 degree is a complete angle, and here we are seeing that 2 pi radian is a complete angle. So 360 degree and 2 pi radian, they are the same thing. 360 degree and 2 pi radian, they are the same thing. So this relation will help me to convert from degree to radian or radian to degree. So in simple words, you can say that if you divide by 2, I will get pi radian equal to 180 degree, and hence 1 radian is equals to 180 upon pi degree, or 1 degree I will say that it is equals to pi upon 180 radian. What is the value of pi? So value of pi, as we all know, it is 22 divided by 7 or 3.14. So the value of pi we will use here is 22 upon 7 or 3.14, but when it is a pi radian, then we will say that it is 180 degree. Okay, so little confusion. Okay, but slowly as we proceed, we will use, okay, these in our problems we will clear. Okay, so let us jump to the exercise 3.1. The first problem is find the radian measure corresponding to the following degree measure. So your first problem is 25 degree and you wanted to convert in radian. So we have discussed that 1 degree, okay, or you can start with from your basics, you can say that 180 degree is equals to pi radian. Therefore 1 degree is equals to pi upon 180 radian. Therefore 25 degree is equals to pi upon 180 into 25 radian. Now you can simplify it. This is equals to with the 25, are we able to cancel? No. So let us cut with 5. So 5 5s are 25, 5 3s are 15, 3 30, 5 6 are 30. So this is 5 pi upon 36 radian. Okay, so it is better to keep our radian in terms of pi only. There is no need that I will substitute pi with 3.14 until and unless there is some specific requirement for that. So 25 degree is equals to 5 pi upon 36 radian. Okay, you can also start directly from this 25 degree is equals to pi upon 180 into 25, or I prefer that you start from this point, that 180 degree is equals to pi radian. Now second angle is minus 47 degree 30 minute. So this second problem is minus 47 degree 30 minute. Now first I will convert this in proper degree measure. So this is equals to minus 47 degree plus 30 minute, which is equals to minus 47 degree plus 30 minute can be written as 30 divided by 60 degree. Okay, so from minute to degree, how we convert? We will divide by 60. So this will give you minus 47 degree, and this is 0.5 plus 0.5 degree, which is minus 47.5 degree. Okay, there is no need that you do all these calculations directly from here. Okay, you can say that this is minus 47.5 degree, or you can say that 47 plus 30 upon 60 is equals to direct calculation you can do in degrees. So now this is degree measure. Again, your 180 degree is equals to pi radian. So therefore minus 47.5 degree is equals to pi upon 180 into minus 47.5 radian. I am converting from degree to radian. So this is what I will do, pi, this minus I will write here, and this I will say that 475 divided by this will become 1800. Now 475 divided by 1800 with 5 I will cancel. So let us do this calculation separately. 475 and 1800 with 5 I can divide. 5 9s are 45, 2 25, 5 5s are 25, then 5 3s are 15, 3 30, 5 6 are 30, then again with 5 I can cancel. 5 1s are 5, 45, 5 9s are 45, here 5 7s are 35, 5 2s are 10, then 19 and 72, they are not cancelling. So here I will say that this is equal to minus 19 pi divided by 72 radian. So this is conversion of minus 47.5 degree. Then we have 240 degree, 520 degree. Now this is easy, you can calculate by yourself. 240 degree, so this 240 degree you have to convert in radian. We will say that 180 degree is pi radian. So therefore 240 degree is equals to pi upon 180 into 240 radian. So this 0 and this 0 I will cancel. Now 6 4s and 6 3s. So this is 4 pi upon 3 radian. Okay, and so on. So this last problem you try yourself, 520 degree and convert it in radian. Now second question is find the degree measure corresponding to the following radian measure and use pi is equals to 22 upon 7. Now here they ask us to use the value of pi. So here we cannot leave at pi, we have to use the value of pi. In the first problem they haven't mentioned anything, therefore we have kept our angle in pi. We have to convert the following radian measure in degree measure. So first question is 11 upon 16 radian. Okay, we have to convert it in degree. So from here I will start. I will say that pi radian is equals to 180 degree. Therefore 11 upon 16 radian is equals to, it will be 180 upon pi into 11 upon 16. Now 180 upon pi, so pi is 22 upon 7, so its reciprocal 1 upon pi will be 7 upon 22 into 11 upon 16. Again 11 1s are 11, 11 2s are 22. Okay, then here we can cancel, this is 90, then we can cancel 2 8s are 16, and here 2 4s are 8, 1 10 2 5s are. So this is, I am getting 45 multiplied by 7 divided by 8. So 7 5s are 35, 3, 7 4s are 28, 28 plus 3 31 divided by 8. Now if you have time you can convert it in decimal, or I will prefer that you keep here. Okay, that is sufficient. So this is your 11 divided by 16 radian is equals to 315 divided by 8 degree. Okay, actually we have to convert here. Okay, why? Because the examiner will also want to see that how we convert this degree in minutes and seconds. Okay, as we are getting degree in decimals, so we have to convert in degree, minute and second. So let us divide. This is we will divide 8 3s are 24, 8 3s are 24, then 7 75, 8 9s are 72, 3 30 is remaining, then I will use decimal 30, 8 3s are 24, then 6 60, 8 7s are 56, then 4 40 and 8 5s are 40. So this is 39.375 degree. So this you will say that 39 degree plus, now this degree I will convert in radian, convert in minute. How I will convert it in minute? This 0.375 I will multiply by 60. So this much minute is there. So now this is 39 degree plus, now somewhere in rough you can calculate. Now 6 5s are 30, 1 0 will be there, 6 5s are 30. Okay, for 30 we have 1 0, 3 carrying, 6 7s are 42, 42 plus 3 45, 4 6 3s are 18, 18 plus 4 22. So 1 2 3, so this is 22.5 minute. Now this will become 39 degree 22 minute plus, now we have 0.5 minute that I will multiply by 60 and this will become second. So this is 39 degree 22 minute, and here when I multiply 0.5 into 60, that means I will get 30. This 30 is in seconds. So I have 11 divided by 16 radian, 11, therefore I have 11 divided by 16 radian is equals to 39 degree 22 minute 30 seconds. Okay, 11 divided by 16 radian. Now this minus 4 in the same way you can do. Let us try this 5 pi upon 3 radian. We have 5 pi upon 3 radian. We have to convert it in degree. So we know that pi radian is equals to 180 degree. Therefore 1 radian is 180 upon pi degree. Therefore 5 pi upon 3 radian is equals to 180 upon pi into 5 pi upon 3. So here this pi will cancel. 3 6 are 18. So this is 60 into 5. So 60 into 5 we have 300. So I will say that therefore 5 pi upon 3 radian is equals to 300 degree. Okay, so this is 300 degree. Pi upon 3 radian is equals to 300 degree. So this is conversion from radian to degree. So we have seen how we can convert from degree to radian and how we convert from radian to degree. Okay, the conversion is very simple. It will be little lengthy as you have to do decimal calculations. Okay, now third question. A wheel make 360 revolution in 1 minute. Through how many radian does it turn in 1 second? So first as you are very much comfortable in degree, first do all calculations in degree and then convert in radian. Okay, a wheel makes 360 revolution in 1 minute. So 1 minute indicate 360 revolution. 1 minute is what? 60 second. So 60 second indicate 360 revolution. Therefore 1 second will imply 360 divided by 60. Okay, what we are doing? We are dividing by 60 revolution. 6 6 है ना, तो this is equal to 6 revolution, right? You can cancel 6 6 are 36, 6 revolution. Now 1 revolution indicates 360 degree. Okay, so therefore 1 revolution indicates 360 degree. You can change at this stage. Therefore 1 revolution indicate 360 degree means 2 pi radian, 180 degree is pi. So therefore 6 revolution, it will indicate 6 into 2 pi is equals to 12 pi radian. Now 6 revolution in 1 second. So therefore, through how many radian does it turn in 1 second? So therefore I will say that in 1 second wheel will turn by, or it will turn through 12 pi radian. Okay, in 1 second it will rotate by 12 pi radian. Fourth question, find the degree measure of angle subtended at the center of a circle of radius 100 cm by an arc of length 22 cm. Okay, so this problem we have done. Let us solve here only. Find the degree measure of the angle subtended at the center of circle of radius 100 cm by an arc of length 22 cm. So here I will say that arc length 100 cm subtends one radian at center. Okay, this is our concept now. Arc length equal to radius will subtend 1 radian at the center. Find the degree measure of the angle. Okay, so we have to find in degree. First we will calculate in radian. Therefore here I will say that arc length of, now in place of 100 they have given 22 cm. So 22 cm subtend 1 upon 100, it will be 1 upon 100 into 22 radian, okay, at center. So this I have to convert in radian. Now this 22 upon 100 radian is equals to 22 upon 100 into, to convert from radian to degree, we have 1 radian equal to, pi radian equal to actually 180 degree. So 180 upon pi we have to multiply by 180 upon pi. Now this is angle in degree. Okay, value of pi, they suggest that use 22 upon 7. So here it is 22 divided by 100 into 1 upon pi will be 7 upon 22. So it is 7 into 180 divided by 22 degree. Now this 22 will cancel, this 10 will cancel, and now I have with 5 I can cancel. So 5 to the 10, or let us keep this as 10. This will help us to convert in degree, okay, in better. 7 8 is 56, 5, 7 in the 7, 7 plus 5, 12. So this is 126 upon 10. Now 126 upon 10 degree. So this you can say as 12.6 degree. So this is your degree measure. Now you will say that find the degree measure of angle subtended at the center of circle of radius 100 cm by an arc length of 22 cm. So you will write in words that therefore 12.6 degree is the angle subtended at the center of a circle of radius 100 cm by an arc of 22 cm. So whenever there is a word problem, your final answer should also be in words. Now fifth question is in a circle of diameter 40 centimeter, the length of chord is 20 centimeter. Find the length of minor arc of the chord in a circle of diameter 40 centimeter. So let us for proper understanding, let us draw a circle. Okay, visual representation is more clear, okay, than written words. The circle of diameter 40. So here the diameter is 40. The length of chord is 20. So here let us draw a chord. Now this chord, say this is AB. This is of length 20 centimeter. This is a diameter of length 40 centimeter. So this is equal to what? This is equal to radius. AB is equal to radius. Find the length of minor arc of the chord. We have to find length of minor arc. Now length of arc, okay, in your previous standard, in 10th standard, I hope you know the formula for length of arc. Now length of arc, what you learned, length of arc is theta upon 360 into 2 pi r, okay, where theta is in degree, where theta is in degree. Okay, so when theta is in degree, we can use the formula length of arc is theta upon 360 into 2 pi r. Now when theta is in radian, then this 360 will replace by 2 pi. When theta is in radians, then your length of arc will be theta upon, in place of 360 I will use 2 pi. Now here your theta is in radian, so this 360 denominator 360 will also be in radian. So this 2 pi and 2 pi will cancel and we will get r theta. So length of arc will be r theta, but your theta should be in radian. Now if it is in degree, we can use theta upon 360 into 2 pi r. Here the question is circle of diameter 40, length of chord 20, find the length of the minor arc of the chord. So here chord is, length of chord is equals to radius of circle. Therefore your angle theta will be 1 radian. Therefore your length of arc, simply we say that length of arc is equals to r theta, na? It is r theta. Here angle is in radian, so it is r theta, where r is equal to 20 centimeter. So this is 20. No, I am doing something wrong. Okay, length of chord is equals to radius of circle. Actually, when arc of chord is equals to radius of circle, we use this thing. Okay, so here theta is not 60 degree. What will be the theta? Theta will be equal to 60 degree. Okay, this will be 60 degree. This is an isosceles triangle. Length of chord is equals to radius of circle. Therefore your triangle OAB is equilateral triangle. Therefore theta is 60 degree. Now angle is in degree, so why to use this radian formula? Let us use that degree formula. So therefore I will say that therefore length of minor arc is equals to 60 upon 360 into 2 pi r. This pi cancels, 6 6 are. So this is equal to pi r upon 3. Now the value of r is 20. You can replace this as 20. So pi is 22 divided by 7 into r is 20 divided by 3. So 7 3s are 21. 20 into 22 is 440 divided by 21. Okay, so you can do this calculation. Let me use calculator for fast calculation, but you have to do it manually. This is what 440 divided by 21. So 20.95. So this is 20.95 centimeter. 20.95 centimeter. This is arc length. Okay. Fifth question done. Sixth question. If in two circle arc of same length subtend angle 60 degree and 75 degree at the center, find the ratio of their radii. So arc length L1 and L2, their angle theta 1 and theta 2 is given. So we have to find R1 and R2, right now? We have to find ratio of R1 and R2. Okay, so if in two circle arc of same length subtend 60 degree and 75 degree. Arc of same length means we have given L1 equal to L2. In some textbook S1, S2 is used. S is for arc length. At some places length L is used. So I use L. So L1, L2 are equal. Theta 1 is 60 degree and theta 2 is 75 degree. We have to find the ratio of radii, that is R1, ratio R2 is question mark. Now L1 is equals to L2. So let us use the formula for L1. It is theta 1 upon 360 into 2 pi R1 is equals to theta 2 upon 360 into 2 pi R2. Okay. So this 2 pi will cancel, this 360 will cancel. Therefore I will say that therefore theta 1 into R1 equal to theta 2 into R2. Therefore R1 upon R2 is equals to theta 2 upon theta 1. Now theta 2 is 75 and theta 1 is 60. So this is 75 upon 60. So with 5 I can cancel. 5 1 the 5. 5 5 is 25. Here 5 in the 5 and 5 2 are 10. Then again with 3 we can cancel. 3 5 are 15 and 3 4 are 12. So 5 upon 4. So therefore R1 upon R2 we have, therefore R1 ratio R2 is equals to 5 ratio 4. Okay. This is from our previous problem. So let us erase that. R1 ratio R2 is 5 ratio 4. And last question from this exercise. Find the angle in radian through which a pendulum swing if the length is 75 centimeter and the tip describe an arc of length. Okay, find the angle in radians through which the pendulum swing. We have to find the value of theta. Find the angle in radian through which the pendulum shift if the length is 75. The length is 75, that length will become radius. And the tip describe an arc of length. Okay, so these are different lengths they have given. For each length we have to find. So I will calculate for one length and then you calculate for rest of the lengths. So here I will use the second question. In this second question, R is given 75 centimeter and arc length L is given 15 centimeter. Okay, we have to find angle in radian. So angle in radian we have to find. So we use the formula for radian. We will say that L is equals to R theta. So therefore this theta is equals to L upon R is equals to L is 15 upon R is 75. So 15 5 are 75. So this is theta is equals to 1 upon 5. Okay, this is 1 upon 5 radian. So therefore theta is 1 upon 5 radian. It is simple to calculate. It is 0.2 radian. So our theta is 0.2 radian. Simple. Theta is 0.2 radian. That's it. So in this exercise, what we learned or what we discussed, we have understood the different measure systems. sexagesimal system, that is degree system and radian system. We understood how to convert from degree to radian, how to convert from radian to degree. I think you know both the major systems. So now onwards, try to express your angles in radians, because this is new. So you have to be good in this system. This is your actually the SI system. So in your other disciplines, in your other subjects, you will find angles in radians. So you have to be very much comfortable with radian angles. Okay. Now we have seen one formula. We have discussed one formula, length of arc, which is r theta when theta is in radian. So majorly, if possible, try to utilize L is equals to r theta where theta is in radian. So you will convert your angles in radian. We have also seen how what are degree and minutes. Okay, degree, minutes and seconds. 1 degree is equals to 60 minutes, 1 minute equal to 60 seconds. Okay, so thank you for being with me in this class. Next class we will see few more formulas, few more concepts related with I think angles, and then we proceed for trigonometric functions. Right? Thank you.